Imagine an engine running smoothly on a freezing winter morning, its parts gliding effortlessly as if warmed up by an invisible hand. Behind this seamless performance lies a marvel of modern engineering: synthetic oil, crafted through a precise and intricate process that transforms raw materials into a high-tech lubricant. Today, we'll uncover the fascinating science and technology that make this possible. This isn't magic, it's the power of synthetic oil. Unlike traditional oils, synthetic oil is engineered for performance at the molecular level. Let's dive into the fascinating story of how it's made, from raw feedstock to the bottle you see on store shelves. To understand synthetic oil, we need to contrast it with traditional motor oil. Traditional oil is refined from crude oil, a naturally occurring mix of hydrocarbons. This process removes some impurities, but many irregular molecules and contaminants remain, which can cause inconsistent performance and faster breakdown inside your engine. However, crude oil is messy, full of impurities and irregular molecules that don't always behave consistently in an engine. These inconsistencies can lead to sludge, deposits, and increased engine wear, especially under extreme conditions. That's why engineers sought a better solution. That's where synthetic oil comes in. An oil made not by simply refining crude, but by building it from selected raw materials with precision. By designing the oil at the molecular level, scientists can create a lubricant that performs reliably in the harshest environments. The journey of synthetic oil begins with the selection of a feedstock, often natural gas or a carefully chosen crude fraction. The choice of feedstock is critical, as it determines the purity and performance potential of the final product. Natural gas is especially prized for its clean, simple molecular structure. Let's break down the process step by step, exploring the advanced technologies and rigorous controls that turn raw materials into high-performance synthetic oil. Step 1. Feedstock selection and conversion. Engineers choose a feedstock based on its potential to produce high-quality base oil. The feedstock is then subjected to high temperatures and pressures in a process called hydrocracking or gas-to-liquid synthesis. These methods break apart large, complex molecules and rearrange them into smaller, more uniform building blocks. Natural gas is a popular choice due to its simplicity and purity. Starting with a cleaner feedstock means fewer impurities to remove later, resulting in a more stable and reliable synthetic oil. The feedstock undergoes a process known as conversion, where it's broken down into its molecular building blocks using advanced techniques like hydrocracking or gas-to-liquid synthesis. This step is crucial for creating a base oil with molecules that are nearly identical in size and shape, ensuring consistent performance. This process rearranges the molecules into smaller, more stable, and perfectly uniform hydrocarbons. The result is a base oil that resists oxidation, maintains its viscosity, and protects your engine better than conventional oils. Step 2. Purification. The converted liquid isn't ready yet. It needs to be purified to remove every trace of unwanted elements like sulfur, nitrogen, and metals. This is achieved through advanced filtration, distillation, and chemical treatments, ensuring the base oil is crystal clear and free from contaminants. This step is crucial in producing a crystal clear base oil, sometimes referred to as Group 4 or PAO base oil, depending on the chemistry. These base oils are prized for their exceptional stability, low volatility, and ability to perform in extreme temperatures. Step 3. Blending with additives. The base oil is then blended with a carefully crafted additive package. This blending is done in high-tech mixing facilities, where precise measurements ensure every batch meets strict quality standards. These additives give synthetic oil its extra powers. Detergents keep engine parts clean by preventing deposits. Antioxidants stop the oil from breaking down when it meets oxygen and heat. Anti-wear agents like zinc compounds coat engine surfaces to protect them under heavy load. Viscosity modifiers, special polymers, allow the oil to stay fluid in cold weather, but resist thinning out when it gets hot. Detergents are essential for modern engines, as they prevent harmful sludge and varnish from forming on critical components, keeping everything running smoothly. Antioxidants extend the life of the oil by neutralizing reactive molecules that can cause the oil to degrade, especially at high temperatures. Anti-wear agents form a protective layer on metal surfaces, reducing friction and wear during engine startup and heavy loads. Viscosity modifiers are engineered polymers that adapt to temperature changes, ensuring the oil flows easily in winter but remains thick enough to protect in summer heat. The blending process is done with incredible precision, using automated systems and real-time monitoring to ensure each batch matches exact specifications. Step 4. testing and quality control. Before the oil can be bottled, it must prove itself in rigorous laboratory tests. Scientists measure viscosity, stability, volatility, and performance under simulated engine conditions, pushing the oil to its limits. Its viscosity, stability, volatility, and overall performance are measured under conditions that mimic the harsh realities of an engine. Only oils that pass every test are approved for sale. Only after passing these strict tests does the synthetic oil earn its place on store shelves, ready to protect your engine from the inside out. So, why go through all this effort? Synthetic oil's engineered molecules and precise additive package enable it to outperform conventional oils in every category, from cold starts to high-temperature protection. Stay fluid in extreme cold, making engine starts easier and reducing wear during the most critical moments. Resist breaking down at high temperatures, protecting the engine longer, and reducing the need for frequent oil changes. Keep engines clean, reducing sludge and deposits, which means better performance and longer engine life. The next time you're at an auto shop, you'll appreciate the story behind that bottle of synthetic oil. It's the result of decades of research, innovation, and quality control. It's not just refined crude oil, it's a carefully engineered, liquid-designed molecule by molecule to keep your engine running smoothly, efficiently, and reliably. If you have any questions or comments, please leave them below. Your input matters. We love hearing from car owners and DIY mechanics. Share your ideas for our next video in the comments, and we'll recognize your contribution. Your feedback helps us create better content for you. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.